right, in section 11.2, we're going to be talking about limits and continuity. And I think that people tend to not like limits very much. I get that. But just power through this, because after this, we get to start taking our first derivatives, and that's a lot more kind of computational, I guess. People tend to enjoy it. So in a previous section, you might remember we learned how to take limits of something that has three components, I hat, j hat, and k hat, but always depended on only one variable, t. Now what we're doing is going to be slightly different. We're going to be talking about limits of a function that only have one component. So there's no I hat, j hat, k hat. We're a scalar valued function f of x, y. But because we depend on both x and y, we take a limit in both x and y to some value. So a little bit different than what we did before. So the limit of f of x, y at a point x0, y0 is just going to be written as the limit as x and y go to x0, y0, f of x, y. And if it exists, we'll write it as some scalar amount L and we'll talk a little bit as we move forward about how to tell if that limit exists. Real quick, I'm just going to tell you that kind of things that you feel about limits are going to be true for this type of limit. Just like things that you felt about limits were true for limits of vector valued functions. And I'm just going to write those out real quick. Oops. So there's the scalar multiple rule that if kind of you are going to multiply your f of x, y by some number, lambda, then it's going to just pull out of the limit like that. All right, whatever. Same way you're used to. And then you've got sums, limit of sum f plus g is the same as the limit of f plus the limit of g. I'm going to suppress all this bottom notation stuff, but hopefully you get the idea that it's that thing right there. Multiples are going to work exactly the same way as they did for functions of one variable. The limit of a product is the same as the product of the limits. And I'm just going to tell you, multiplication and division are the same thing. So if you have the product rule, you have the quotient rule. All of this to say that you don't need to write these things down or commit them to memory. Probably there's something that you intuitively feel you can do with limits already. And I'm just telling you, you can still do those things. How are we doing on time? Yeah, okay. And taking a limit when the limit exists is going to be pretty much the same as you're used to as well. Actually, I'll write that. So when the limit exists, computation of that limit is similar to when you had some function y equal to f of x and tried to take a limit of that. And so we'll demonstrate that taking the limit as x and y both approach the point 0, 0 of the function x squared plus x minus xy minus y over x minus y. This looks really messy, but I'm just going to tell you that we can factor this x squared plus x minus xy minus y into x plus 1 times x minus y all over x minus y. And so those two things cancel out, x minus y on the top and bottom. Whoops, I lost my limit notation. So I'm just going to put all that stuff right there and then rewrite my limit down here. So if I'm taking this limit to 0, 0, and I wanted to take it of this x squared plus x minus xy minus y all over x minus y, I know that's the same as the limit as x and y both go to the point 0, 0 of x plus 1. But if I just plug in x equals 0, I just get that that's 0 plus 1 is 1. That would be my answer for evaluating this limit. And so hopefully that feels familiar. You just basically get it to a point where you can plug in a number and then evaluate it. One thing that's important to note is what I did here is sort of saying, well, not even that x minus y isn't equal to 0, but that x and y aren't the same. Or else that's dividing by 0 when I cancel out these terms in the numerator and denominator. And that can feel kind of like cheating because I'm trying to go to the point 0, 0 where x and y are clearly the same thing. But that's okay because we're only approaching the point 0, 0 where x and y would both be the same value, 0. This is something that's kind of always true about limits. And I think that students are always a little bit uncomfortable with it. So I just wanted to make sure to be upfront about that is still happening and it's still okay.